Hello everyone. I want to make this short video for Lab 1. I had a couple students call me or text me. It might have been just a little bit of confusion on exactly what you're doing or how the circuit works here. So I thought I would run through it real fast. It is due tomorrow. So hopefully if you weren't sure on exactly what to do, this helps out. So what we have here is called the start-stop circuit, and we actually talked about this circuit the first day of class. We talked about the sealing circuit, and you might want to review the video, the first or second video, but I'll just kind of run through it here. This is a normally closed push button. This is a normally open push button. So if I didn't have this contact here, then when I push the start button, remember this acts like a doorbell, so when I release it, it's going to go back up. When I push the start button, there's power flow through the circuit and the relay coil will energize. The problem is when I release this, since it acts like a doorbell, that's going to open back up, and when I release it, this is going to turn off. So what I like to happen, I like to be able to push this button and have this latch on, this a latch, or have it seal on, seal in. And so the way you do that is I'm going to put a parallel normally open contact here. So I have a switch here and a switch here. So that's OR logic. The problem is this will not close until the coil is energized. Notice that the coil appears here and the word coil appears here. Well, what that's referring to is the address. This is the address. This is trying to indicate that this coil controls this contact, so they give them the same address, and I just used the word coil here for the address. So now what happens, if I push the start button, there's power flow through the stop switch since it's normally closed. As long as I have this pushed, the coil will energize, but when the coil energizes, it closes this. So now there's two paths. There's this path to the coil to energize it, as long as I have that button pushed, and there's this path. When I release this, I still have this path right here. So now this thing is latched on. To stop it, that's the stop button, has to interrupt the current. And so the object is to you want to build this in Logix Pro, but the whole point of Lab 1 is to understand that we're really not talking about current continuity. We're talking about logic continuity. So you want to go back and look at those PowerPoints and understand the idea of logic continuity. So figure B, if you translate the actual hardwired circuit to a program using not logic for the stop switch, since that's normally closed, you would normally translate that as a normally closed contact. This is normally open. So if you translate these for what they are, symbol by symbol, this is normally closed, so this is normally closed. This is normally open, so this is normally open. And then you have your contacts and your coil. So this down here is the actual program. And the point is, this will not work correctly. And to explain that, you need to understand what we mean by logic continuity. It is the correct circuit for current continuity. I mean, you translate these instruction by instruction, physical switch normally closed to the not or stop, normally open, normally open, normally open, normally open, coil, coil. So if you translate them symbol by symbol, this would be the correct circuit, but it does not display the correct logic. What you want to happen is when you press the start button, you want the coil to energize, and when you release the start button, you want this coil to stay energized. And when you press the stop button, you want the coil to de-energize. And you'll see if you translate this normally closed, normally open, normally open. If you translate these exactly as they're shown in the actual hardwired circuit, this will not function correctly. Figure B will not function correctly because it's the incorrect logic continuity. If you move down to the program B in figure C, this is the correct logic continuity. So when you When you actually run this in your simulator, you should see that when you press the button connected to the start, it'll latch this and the stop will unlatch it. And so your job is to understand what we mean by logic continuity, and then to show that this does in fact work incorrectly and figure C works correctly. So hopefully, if you had some confusion, I know it was one person was confused over the term coil here and coil here. In your simulation software, you just want to make sure you give this output and this coil, that instruction, you want to give them the same address. Give them the same address. If you name this coil and you name that coil, then you give that coil an address, and then you can drag the address over here. It'll automatically name itself coil. But the point is, again, this address needs to match this address, and that's for any latch or sealing circuit. That's always the case. This output address will match this is the actual latch right here. It will match the address of the latch. So hopefully that helps out. If not, you still got the rest of today and tomorrow, part of tomorrow, to turn it in. So if that doesn't help out, then send me a text, and I'll see what I can do. Other than that, guys, have a great rest of the day, and we'll see you soon.